So, good afternoon for all of you. Really sorry for the delay. You guys can hear me, right? Can someone confirm me whether it's clear for you? Whether you can hear me?
Yeah.
Oh,
Yeah. Yes.
okay. So now we have only 18 students here for the session. So I asked assistant lecturer to uh, change the LMS link which they have provided, so that I mean the Zoom link which they have provided. So now the new link for the entire lecture series will be this. So anyway, I will be doing the introduction to data visualization and management lecture course module. So for you, I did Microsoft Office as well. So here for the introduction to data management and data visualization and management course module also, there we have two topics to cover. One is about data visualization. The other one is about data management. So first, I will be doing about a few main stuffs on data visualizations and then move to data management stuff. Okay. So here, what do we have now? So we will be talking about data visualization, the basic stuffs of data visualization on this today's lesson. If you have any questions, just ask from me. Please listen carefully. At the end, you will have to do a quiz. That will be the continuous assessments for each and every day. I'll give you a kind of a quiz to complete and submit it within the lecture, within the class itself. Those who have come to the lecture, those who have logged into the lecture, they can, no problem, they can easily do it and submit it. So that will be taken as a data visualization continuous management. So I will be given you those quizzes each and every day. Okay, so those will be the continuous assessments. Not only those ones, we will be considering about the lab worksheets, lab practical submissions, as well as the attendance as well for the practicals, as both practical and the whatever we call the lecture, for both. The attendance will be calculating for both. Those are the few things I should tell you before starting the lesson. So I will be starting the lesson right now. Any questions from the previous badges? Okay, nothing. Okay, now today we will be talking about data visualization. Now tell me, first, choose one aspect of your daily life for which you can recall 4 points. What do you mean? What do you mean by that? First, choose one aspect of your daily life for which you can recall 4 data points. What does that mean? Data points හතරක් ඔයාට හොයාගන්න පුළුවන් වෙන විදිහට data points හතරක් ඔයාට හොයාගන්න පුළුවන් වෙන විදිහට මොන හරි daily. Why? No, now you guys are in English. Now you guys are in second year. I'm not explaining in singular further because you have to move now. So first year that would be acceptable to do in both languages, but now I'm not. I'm completely explaining in English. So you guys have to come to the lesson. You have to listen the recordings carefully multiple times and then learn these words. No single explanations for this unit. Okay. So first, choose one aspect of your daily life for which you can recall four data points. Okay, now tell me some examples at a glance, whatever you can recall as four data points. What are those ones? Give me an examples. One aspect of your daily life for which you can recall four data points. What are those? Maybe sometimes brush your teeth. If someone asks from you whether you brush your teeth today, you might tell the answers as yes or no. And also, someone will tell you how many cups of teas you will consume per day. Daily consumption as the daily consumptions of cup of teas. Someone will answer, maybe it's one, maybe it's two, maybe it's three, anything. We don't know. So these are kind of few daily aspects where you can recall four data points. Okay. Now, if I ask you to create a Google Slides file with a blank slide, how are you gonna create it? If I ask you to create a Google slide, with a blank slide, then how are you gonna do it? What are the steps you have to follow? Tell me. What are the steps you have to follow? Tell me quickly. First, create a Google Slides file with a blank slide. Then how you gonna do it? Anyway, first you have to log into your Google account. And then from the right side of it, there you can see this presentation slides options. So if I show you how you're gonna do this, let me first stop the sharings and then let me share my screen. Okay. So once you see, once you logged into your Google account, it will show this interface. Then what will happen on here? You have the slides option. When you select on this, when you click on the slides option, then it will navigate you to this kind of a interface. Once you come into this kind of interface, then you can select a blank presentation to create a blank presentation. That is how we normally do or create the presentations in Google Slides. Now, what will happen? That's what here they have mentioned. So here to create a Google Slides file with a blank slide, those are the steps you have to follow. Okay. If I ask you to do it now, can you try it now? If I ask you to do it now, can you try it now? If I ask you to do it now, can you try it now? So my second step would be on your blank slide, okay, on your blank slide, draw a simple visualization of your 4 data points. Now our 4 data points would be, the first one is what? The first one was actually whether you brush your teeth or not. There you got an answer if you brushed. If you brush your teeth already, then it would be yes. If not, it would be blank. That is what we had earlier. Okay. That was one thing. And the second thing was the daily consumption of the cup of teas. Then we got the answer as 3. So there we have 4 data points. So now for those aspects also, you can select your own aspect. My task for you is to draw a simple visualization of your 4 data points. Now what we have to do? So when we ask you to draw a simple visualizations of your 4 data points, you can use scribbles. Not only that, you can use shapes. Okay? Do not use diagrams. For this part, do not use diagrams. Then the next step would be create another Google Slides file with a blank slide. Then the next step would be create another Google Slides file with a blank slide. How we gonna create another Google slide with a blank slide? Again, we have to use the same process. You have to follow the same process and create it. That is there. Then write a set of instructions. Write a set of instructions. So another classmate will be able to recreate your visualization in under 3 minutes. Now what will happen? Now they have asked us to write a set of instructions. Write a set of instructions. So another classmate will be able to recreate your visualization in under 3 minutes because we have already guided them. We have already given them the instructions how you're gonna create it. Okay. Then the next step is copy an editable link to your instructions. We can copy an editable link to our instructions and share it with the other people as well. So now find someone in the classroom which you are not sitting directly next to and go sit with them temporarily. Now, if I ask you to find a friend, find someone in your batch who you are not sitting directly next to and go sit with them temporarily. So there you can establish some patterns. Tell me, do you have friends always where you go and sit together during the lectures? So then say hi and introduce yourself, but not your data. So you have to go there and you have to introduce who you are, but not anything about what about the data. That's what there we have. Our next session would be message your instructions URL to your partner. Now you can message your instructions URL to your partner, but not their visualization actually. So here, if we create a second slide in your partner's file, if we create a second slide in your partner's file, then draw according to his or her or their instructions. Then draw according to his or her or their occasions as well. Now what we have to do? Now copy your original drawings. Now copy your original drawings from your first file to your instructions. That means your instructions is available on your second file. Then what we have to do? We have to copy our original drawings from our first file to our instructions file. Then again, we can look over the results with our partners, with our friends, and discuss all the other drawings, discuss about all the other drawings. So we can take turns considering the instructions and how they were interrupted as well. When it comes to interrupted, maybe what we have to come up with new questions. One will be what was a surprise? The other one will be what was unexpected. කොහොමටත් ඔගොල්ලෝ බලාපොරොත්තු වෙන්න කියපු එක what was unexpected and the other one is පුදුම වෙච්ච දෙක. බලාපොරොත්තු වෙන්නේ නැතුව ගියපු දෙක. That's all about the visualizations. Now we will be moving to these topics with theories nicely. Okay? Okay. First recall these ones. හරි? එතකොට දැන් මොකද වෙන්නේ? අපි මේ කරන්න යන එකේදී, so now what is our course module's name? Our course module's name is data visualization. That means anyway we have to do the visualization. හරිද? If we have to do the visualization, then what do we have to have? මොනවාද අපි ගාව තියෙන්න ඕනේ? Then we should have our raw data. Okay, we should have our raw data. Very first thing it would be we should have our raw data. අපි ගාව අමුදත තියෙන්න ඕනේ. Then what will happen? Next, first, at last, if we wanted to have a visualization, before that, as the very first thing, we have to do the design. How are we gonna do the design? Design is from visual encoding. Okay, we can use the visual encoding stuff and do the design. And then we can do the describe. We can do the describe part with the code. And at last, we can have the visualization. So then that is the entire process of data visualization. First, we have to have the raw data. And second, we should have the design part. If we have the design part, that means we have the visual encoding. And as the third part, we have the describe part. There we have to describe the code. And at last, we should have the visualization. So these are the all 4 steps which we follow normally, roughly in visualization. So then the next one. That was the basic background, basic steps now. So now in here, I have added another 2 steps. One is wrangle, the other one is the analyze part. Then how the new life cycle or the new steps work? First we have the raw data, and then we can have the wrangle. Then as the third one, we have the analyze, and as the fourth one, we have the design, and as the fifth step, we have the describe, and at last, we have the visualization part as well. These are the steps from raw data to visualizations. These are the steps from raw data to visualization, which we follow normal. Okay. So now these are not one directional sides, unidirectional one. These are not unidirectional. That means always straight or always from one side. You can see there are a few curves as well. That means, so how this cycle works from raw data to wrangle to analyze. Once we create this analyze, again maybe we are step back to the wrangle part, and then again we'll do some modifications under this wrangle. Again we will move to analyze part. Once we completed this analyze visual analysis part, then we will be moving to design part. Once we move this design part, sometimes we might have to come to the previous step as well, which we call the visual analysis. Likewise, you have to pay a kind of a good attention for these arrows and see what are those steps and how the entire cycle works. That's what here we have. Okay. Then my first question is why we visualize? My first question is why we visualize? What do you think? Why we visualize? Any answers? What do you think? Why we visualize this? Why we do these visualizations? So the reasons are not only that, there are like more questions as well. Another question is how much data is in the digital universe? How much data is in the digital universe? So these are kind of few questions. What do you think? How much data is in the digital universe now? In 2024, as of 2024, we have 147 amount zettabytes, that is 10 to the power of 21. Even we can't think about that as well. This amount of data are there for each and every second. We are generating more and more data as well. So before we are going to answer this, why we visualize, we should have a look on how much data is in the digital universe. How much data is in the digital universe. So there, as of 2024, 147 zettabytes amount of data is there. That is actually 10 to the power of 21. Okay. So now these ones are kind of some, you and me, you and I, maybe both of us haven't seen these kind of visualizations. When it comes to visualizations, you all think that the bar charts, histograms, box plots, and the other tables, those are the only visualizations we have here. But it's not like that. There are many more visualizations which you can use, which you can see in your day-to-day life, which will affect or which will help our day-to-day life in each and every second. See, now this one is about the physical sensors. So you can see the physical sensors where we have located. Okay. This is a one visualization. This is not a bar chart or histogram or box plot. This is kind of a special, relevant map or something. We can say it's also again kind of a map here. Okay. Now this one is the bioinformatics side. How we gonna use the bioinformatics sides? How we gonna express or how we gonna display these bioinformatics ones here? See an example for that. Records of human activity. Even I haven't used these kind of charts and these kind of models or these kind of visualizations in my life as well. See, records of human activity. Those are kind of few new, what do we call, new visualizations which we are using in 2024. Okay. Okay. Then we have the systems. What are those systems? The next topic would be systems. So what is the system here? We have data. Once we have data, we have to input. Which properties do you want to feed in? We should think and do the input. Then there might be few hidden layers as well, which those data should go through. At last, we are having the output. This is the entire systems which we have in data visualization. So again, I'm getting a question. This question is, how does visualization help make sense of this mass of data? How does visualization help? How does visualization help make sense of this mass of data? How does visualization help make sense of this mass of data? What do you think? Now we have the visualization definitions. What do we mean by visualizations? What is it? What do we mean by visualizations? What is it? What is visualization? Visualization means finding the artificial memory that best supports your natural means of perception. Visualization means find in the artificial memory that best supports our natural means of perceptions. Perceptions means our aramun. Find in the artificial memory that best supports our natural means of perceptions. That is Bertie in 1967. So the use of computer generated, another another example would be the use of computer generated or interactive or visual representations of data to amplify cognition as well. That is what we call the use of computer generated interactive visual representations of data to amplify cognitions. That's what here we have. See now what you can see from this. Okay, first check. Give me some comments. So what has happened? So what do you think? What do we have here? We have 4 columns. Okay. Under that, actually we have 4 data sets. So in a single data set, we have X and Y. Maybe the X would be the input values, Y would be the output values. So what are the things you can say, you can interpret by looking at this? What are the things you can say by looking at this interpretation? What do you think? So here we have anyway 4 columns. With each and every column we have x and y values as well. So here x and y, maybe x would be the, in our general terms, we would say x would be the input values and y would be the output values. So likewise, we have 4 separate data sets. So now what are the things we can say? Maybe there are students who study statistics as well. Maybe sometimes there are students who have done some data kind of information. So here we can, since all these data are numeric data, then we can calculate the mean and variance accordingly. The mean and the variance accordingly for this entire data set. Okay, that's also there. So maybe the mean would be for the first data set, the mean would be 9. And for the second data set, for the Y data set, the mean would be 7.5. Then for the sigma means anyway the variance, right? You can see that the sigma value is here. That means the variance. So the variance of X data set and the variance of Y data set means the variance of X data set means 11 and the variance of Y data set means 4.125. Okay, these are the means and variance which we can calculate from the given data set. Then we have the linear regression equation that has been mapped. That is kind of a relationship in between mean and x values and the y values. That means the x data set and the y data set. So we have found that the both data sets has a kind of a relationship in between x and y. That means the input values and the output values we don't know, but that's exactly. But anyway, we'll assume like that. The equation would be a linear equation, that is y is equals to 3 plus 0.5 times x. And the r squared value, that is the correlation coefficient or the r squared value. So the r squared value would be 0.67. R squared value would be 0.67. So these are kind of few mathematical informations or else numerical values which they have given us after calculations all these data. Okay. Then data sets with the same statistics can be vastly different. Data sets with the same statistics can be vastly different. That means here we have what? Data sets with the same statistics can be vastly different. See, what about the first one? X1. What you can see? X1 is a little bit. It's a kind of a moderate level linear relationship. But in X2, do we have a linear relationship there? No. But in X3, we have a linear relationship, a proper linear relationship. But in X4, do we have a linear relationship there? Yes, but it's not kind of the best fitted line. Likewise, we should be able to provide comments, provide our feedback, provide our thoughts, or provide our opinions on whatever they have given as a data visualization type. See, another visualization type is here. Now we have the spectrum of visualization goals. Now we have the spectrum of visualization goals. What are the steps? First, we have to explore, and then we have to explain, and at last we have to exhibit. First, we have to explore, then explain. After that, we have to exhibit. Explore, ගවේෂණය කරනවා, explain, විස්තර කරනවා, exhibit, නිරූපණය කරනවා or else ප්‍රදර්ශනය කරනවා. ඔය තුන තමයි the spectrum of visualization goals. How are we gonna explore the stuffs? Here we are in the first step or the first stage of exploration. The first one is explore. Second one is explain. We'll mention all these stuffs in detail. We'll explain. And in third one, exhibit. We are displaying something. Now, what are the goals of visualizations? What are the goals of visualizations? Here we have. When it comes to goals of visualizations, mainly we have two types of goals. One is exploratory, the other one is explanatory. First one is exploratory, the other one is explanatory. For the exploratory, that means to uncover a relationship in the data, to analyze data, to uncover a relationship in the data, or else under this exploratory part, we will be doing it to analyze all these data. Then explanatory is the other goal, that is to communicate a relationship in the data. Communicate a relationship in the data. Communicate a relationship in the data. Or else we can use this explanatory part, to present all these data. Then you should know what are the two main goals of visualizations. One is exploratory, the other one is explanatory. Exploratory means to uncover a relationship in the data and also to analyze all these data. Explanatory means to communicate a relationship in the data or else to present all these data as well. Now, the next one, the field of visualization. Now, the next one, the field of visualization. When it comes to fields of visualization, these are kind of very few fields of visualization. We have the design. We have the HCI part. HCI means in computer, we would say human computer interaction part. Then we have the computer graphics. Then we have the cartography. And then we have the statistics. And at last, we have the psychology as well. Design, HCI, computer graphics, cartography, and then we have the statistics, and at last we have the psychology as well. These are the few what? These are the few fields of visualization. The visualization will connect with each and every field of these ones. See, the blue color set is the visualization. If we consider about visualization, there we have a design part, there we have a human HCI, human computer interaction part, and then the computer graphic parts. Not only that, there we have the cartography part and also a statistics part. At last, we have the psychology part as well. These are kind of few things which we should know. Okay? Then we have the origins. What do you think about the origins? In earlier 1786, William Playfair, inventor of line charts, bar charts, and the pie charts. See, 1786 by William Playfair, inventor, who is the inventor of the line charts, inventor of the bar charts, and also inventor of the pie charts. Florence Nightingale, that is 1858. Who is that? Florence Nightingale is the, who is that? Legend, we would say red, black, blue. That means our B, the colors. Red would be wounds, black would be other, the blue would be disease. Likewise, these charts led to better hygiene in military medicine, saving millions of soldiers' lives. See, that is for the Florence Nightingale in 1858. Then we have what? Charles Joseph Minard. Charles Joseph Minard also in 1869. Jacques Bertin, 1967. So these are the main persons who invent or introduce few things in data visualization. That's what here we have. Now, what is data visualization? Now, what is data visualization? That is transform data into visual encoding. Transform data into visual encoding. Or else it can be using special properties. Also, it can be using special properties of the visual system to help us think. Then maybe your visual system is good at specific tasks as well. But all these visualizations are made from a series of promises. So all these visualizations are made from a series of compromises. So the transform data into visual encodings using special properties of the visual system to help us think. That is, your visual system is good at specific tasks. And also, all these visualizations are made from a series of compromises as well. That's what we have. The role of perception. What do you think about the role of perception? For this role of perception, there we have to, when it comes to role of perception, when it comes to role of perception, there you have to compare and there you have to think about the size and the position as well. Size and also about the position. One thing is size, the other thing is the position. Okay. One thing is size, the other one is the position. Then we can compare the area of the circles as well. So the first one, it would be much smaller. The second one, it would be much bigger. Okay. Then we can compare the length of bars as well. The first one, it would be much lengthier. But the second one, it would be much shorter. Now, then the next one, compare area of circles. There we have the circles, and also for the first one, we have only one circle, but for the second one, we have multiple circles as well. See the compare area of circles. Compare length of bars. For the first one, here we have 7 squares. But for the second one, we have only 1 square at all. Now the first chart. First chart is a pie chart. Second chart is a bar chart. Yes. Again, the role of perception. Not only from the size and the position, we have to think about the color as well. Not only about the role of the perception, we have to think about the color as well. There we can see these ones. Multicolors. See? The color changes. See the color changes. There are so many color patterns also. So here we have the first one is the sequential. Then the second one is the diverging. Then the third one is the categorical as well. Okay, sequential, diverging, and then the categorical. These are kind of few options which we have. Color combinations, which we can use. Then attention and the pop-out. See the differences. When it comes to role of perceptions, we have earlier we talk about the color. Before that, we talk about the size and the positions. Now we are talking about what? Now we are talking about the attention and the pop-out. See, they're asking how many occurrences of fives are there? How many occurrences of fives are there? How many occurrences of fives are there? You can count. That is, we have to pay our attention and check for the results. Pop out. See, now here we have use of visual styles to convey feeling. Use of visual styles to convey feelings. What are these ones? Maybe here we can have a sad mood, we can have a angry mood, we can have a happy mood. Maybe we don't know. We just wanted to convey or express our feelings. No, we don't know that. Another few questions which we can find out. Which company has more sales? That can be the total sales. If we are expressing about the total sales, then we have company A, company B, as well as company C as well. And also, you should pay your attention. We might miss representation. We might miss representation sometimes, often with best of intentions as well. Misrepresentation, often with best of intentions as well. There are few, maybe we might misleading something as well. Misrepresentations. Here also we have another thing for now to compare what would be the best, what would be the good option here. We can compare these options here. Share of the men, the sons of black families from the top 1% had about the same chance of being incarcerated. on a given day as the sons of white families earning 36,000. Incarcerated. Then here we have another visualizations. Arab Spring. These are really new things. 2024 updated versions. Can we use these kind of visualizations to understand algorithms? It's up to you. You have to comment on these ones. Can we use visualizations to help uncover the biasness? You should think about that. See, can we use visualizations to help uncover the biasness? That should be there. See, the visualizations, interactive visualizations. Have you ever seen these kind of visualizations? I don't think so. These are latest ones. See, histograms, pie charts, bar charts are not only or not one and only, not only visualizations which we should know. These are the few visualizations you should know and you should have been seeing these kind of ones. It's very beneficial. See the designing ones. We can draw and we can express, we can implement the stuffs as well. Explorations. Explorations. And now we will be moving about the data models. When it comes to data models, there we have attribute types as well as ordering directions as well. When it comes to attribute types, there might be categorical ones, there might be the ordered ones. Anyway, when it comes to data can be divided into two parts. One is two categories. One is quantitative, the other one is qualitative. One is quantitative, the other one is qualitative. If it's quantitative, that means, what? If it's quantitative, that means in Sinhala we call them as Pramanatmaka. If it's qualitative, that means if it's quantitative, that means anyway, it would be, if it's quantitative anyway, that would be quantity, Pramanatmaka. The other method is the qualitative one, that is Gunatmaka. If it's qualitative, that means Gunatmaka. So when it comes to categorical, again, it would be qualitative one. And also for this categorical options, categorical data, we can have multiple data types. One is ordered. The other one is numerical. What else? These are the, one is ordinal, the other one is nominal. These are the two types of categorical variables which we have. Okay, these are the two types of categorical variables which we have. One is ordinal, the other one is ordinal, the other one is nominal. Yes, here they have mentioned when it categorical, it can be ordinal. Ordinal means actually what? Ordinal means actually what? That is, ordinal means for all those kind of data we have what? For all those kind of data we have an order. If we have an order, that means there we have the ordinal ones. For the ordering directions, so here see, you can see that when it comes to categorical data, it can be, we can use these shapes and show. If it's ordered now, again, we can use a pictorial one to represent that. From the smaller to the larger one. See the t-shirt sizes. Then for the quantitative one, if it's a length related stuff now, then we can have it for the smallest one to the largest one. For the ordering directions, here we have so here we have the quantitative ones. See, if it's lengthier one, then we can have from shortest to the largest. For the order in direction, it can be either sequential, it can be either diverging, or it can be either cyclic as well. If it's sequential, that means one-sided. If it's diverging, that means for both sided. If it's cyclic, that means again it could be a cycle. So then here we have, what do we have? You can see the graphs as well. These attribute types and the ordering directions we can draw as a chart as well. We can draw as a chart as well. Visual encodings. These are kind of few examples which we can have. See the perceptions. When it comes to perceptions, not only size, not only position, not only color, there are so many things, magnitude channels, ordered attributes. It can be either position on common scale, position on unaligned scales, length, tilt or angle, area, depth, color luminance, and color saturations, curvatures, volume, all these ones are there. Okay. So here, then we have the evaluation. Then there should be a method which we have to have, which we can evaluate, these data as well. Then when it comes to evaluations, that means so here, when it comes to evaluations, we have characterizing the problems of real world users, the first one. Then we have to abstracting into operations on data types. Then we have the, thank you. Then we have the designing visual, then we have the designing visual encoding and interaction techniques as well. And at last, we have the creating algorithms to execute techniques efficiently. So these are the steps which we have to follow when we do the evaluation. Okay. First, we have to characterize the problems of real world users, and then we should abstract into operations on data types, and then we have to designing all the visual encodings and interaction techniques, and at last we have to create. So for creating algorithms to execute techniques efficiently. Now here we have the interaction. See, now when it comes to interactions, we have x-axis as well as the y-axis. We have x-axis as well as the y-axis. Now what does that mean? We have drawn a scatter plot. Can you see how the interaction works? Can you see how the interaction works? See, there are so many changes and interactive ones. Maps, another visualization technique. Colors, we have to think about the colors as well. Narratives, animations, networks, text, algorithms. So these are few things which we have to pay our attention when we do these visualizations. When it comes to fundamentals, we have to think about designing data models, data explorations, visual encodings, interaction, perception and evaluation as well. Then for the techniques, we have narrative, animation. Then at last, we have topics. Under these topics, we have text, networks, algorithms, and at last, we have ethics, uncertainty, and finally, the research options as well. So what are the 5 main assignments in teams? The first one, sparks. Second one, design. Third one, explorations. And as the last two, we have interactivity and also the final project. Interactivity and also the final projects. Okay. So then only 3 slides more. So I'll be doing these 3 slides as well. 5 main assignments in teams. First one, it is sparks. The second one, it is design. Third one, it is exploration. Fourth one, it is interactivity. And final, we have the final project. When it comes to sparks, teams, process, philosophy is there. Design, ideation, iteration, and the critique is there. For exploration, data wrangling analysis is there. Interactivity, complexity, animation, narrative is there. And for the final project, we have the synthesis as there. These are kind of few things which you should pay your attention. Here we have the Tableau. For Tableau, we have the Tableau is kind of a tool which we are using for data visualizations. D3, these are according to your choice, according to the pros and cons and the features, what is available. You can use any kind of visualization tool. Learning approaches. When we do these visualizations, we should know about the principles, we should know about the practices, we should know about the peer learnings, we should know about the programmings as well. And at last, we have the examples of past final projects. These are the few things. That's all for the first session. That's all for the first session. Okay. So thank you so much for joining. I'll publish the quiz within today So it is kind of a limited time period you have to complete. So since I got delayed to start the lesson, okay, anyway, okay, we'll do like this. We'll do the quiz next week. That's fine. We'll do both quizzes next week. I have already created that one and uploaded to TestMoss. Okay, then we'll do the quiz next week. No problem. Thank you so much for joining. See you on next week then. Bye.